What's up? What's up? It's your man Jimmy Chan. All right, so today we're talking about properties of logarithms. So here is a couple of simple properties. Now, again, each column is repeating itself, right? This column right here is a traditional log base of some number, okay, of x. This is just talking about the same exact properties as these ones, except as a natural log, and this is as a common log, which is a base of 10. So don't look at this and be overwhelmed by it because it's essentially saying the same thing 3 times. All right, so don't be overwhelmed by it. So let's talk about some of these examples, right? So let's just talk about this first one right here. This first one right here, when you take the log base of anything of 1 is always equal to 0. So why do we know that? It's because of this graph right here. So this is the graph of log base b of x, or x equals b to the y. And what we have here is a point 1, 0. That means if I take the log of 1, which is my x, it will equal to 0. So that point right there is what this statement is showing right there, okay? So I highlight those two in yellow, all right? Now, the rest of this here is just talking about opposite operations. So what I'm going to do now is I'm going to show you another way of converting the exponent form of logarithmic function into a log form of the logarithmic function. Right? There is another way. So it's not just saying, hey, the b doesn't want to be the base here anymore, right? That story might have confused you. Like if that story confused you, then you might want to learn how to use the opposite operation. So if I want to get y down from that power, right, and be normal, then I want to use opposite operations. How do I do that? What I want to do is look at this base here, okay? And what I'm going to do is, based on that base, because that base is a b, I'm going to use a log base b. Okay? So what does log base b do? And if this base right here was an e, I would use the natural log. If this base was a 10, then I would use a common log. Okay? So now if I take the log base b here of both sides, okay, this is what happens, is that these two right here are so-called opposite operations, and that is showing you this right here. Look at that, right here, okay? So log base b of b, essentially what happens is that it cancels each other out. So all it's left is just the y. So that's going to equal to log base b of x, which that should look exactly like this right here, which is a log function. The log form of the logarithmic function, and this is the exponent form of the logarithmic function, okay? So that is the opposite operation, which I just showed you right here, right? That's what just happened. Now, if the power wasn't there, wouldn't the power be just to the first power, right? It would just be the first power. And since these cancel, I would just have the 1 left. That's why it's a 1, okay? So again, these two here are really saying the same thing, except reminding you that this power is a to the first power, okay? All right, so what about this last part here? Well, let's go ahead and convert the log form to exponential form, okay? So with this case, now remember the logarithmic function and the exponential function are inverses of each other, okay? They're actually opposite operations of each other as well, okay? So let me go ahead and duplicate this. So this is what we're going to do. So because that this base here is a b, okay? So if this base was a b, then I will use b as my base for a power. If the base was a 10, then the 10 would be a base to a power. and this was the e, then e would be the base raised to a power. So in this case, I'm going to take b raised to this power, okay? And if I do that on this side, I got to do b raised to this power, okay? And the b looks sad. So let me go and write this b here and the b here a little bit better, okay? So I'm taking b and raising it to a power, all right? So on the left side, it is what it is. It is b to the y, okay? And that's going to equal to what's going on this side. Well, because that these two bases are the same, as I showed right here, since these two bases are the same, these go away and left with just m. So again, these kind of cancel each other out. So all I have left is just that x. So now this right here should look very much like my exponent form of my logarithmic function, which you guys can see right here, right? X equals b to the y, x equals b to the y. So I could use opposite operation to do exactly the same thing, all right? So that kind of shows off those opposite operations. And you're going to need to know those opposite operations. Now, here's another type of problem that you might run into, all right? So anytime I see a base, my goal is to try to make what I'm taking the log of with the same base. And I can make 25 as a base of 5. So let's do this. Let's make this red. So I can do log base 5, and 25 I know is 5 squared. Now look at what just happened here, right? Aren't those opposite operations? Yes, they are. So these actually go away. And so what do I have left as an answer? Is 2. So that would be my answer right there. All right, and just like that. All right, perfect. Now, let's get into a little bit still simple stuff, right? So here is telling me that, hey, if the log base are on the same side, then the inside must be the same, right? If I raise if the bases are the same, then the powers must be the same. So let's take a look. So right here is perfect. 2 raised to x is equal to 2 to the 5th. Well, if I saw this, wouldn't I just say, well, x has to equal to 5 because the only way for 2 to the x is equal to 2 to the 5, then this x must be 5, right? Boom, done. That's pretty easy. Don't worry, you won't get easy problems like that. However, you will get problems more like this right here, right? So what I want to do is I want to try to make the base the exact same, right? So I know that 2 raised to this power. Great. So question is, can I make 64 with a base of 2 as well? So I have this right here on this side. Great. Let me just bring it down. So the question is, 2 to what power would give me 64? Well, 2 to the 6th would give me 64, right? Because if you think about it, 2 to the 1st is 2, 2 squared is 4, 2 to the 3rd is 8, 2 to the 4th is 16, 2 to the 5th is 32, and then 2 to the 6th will be 64. So since the bases are the same, that means I must have this equation of 2x plus 3 is equal to 6. So then I can solve. 2x is equal to 3, so x must equal to 3 halves. And there I go. All right. All right, so let's go a little bit more in depth in terms of what I can and cannot do here. So let me go ahead and, so this is a little bit more difficult right here, okay? So when I look at this problem here, the question is, what can I make these two bases to be the same? And let me go ahead and turn these here into red. All right, so what I can do with the 1/3 is that 1/3 is 3 to the negative 1 power. And it's going to be raised to this power here. Awesome. And that's going to equal to 9 is 3 squared. and it's going to be raised to this power, right? So again, my base are exactly the same. Awesome. So the question is, what do I do with a power raised to a power? Well, if you remember exponent rules, I multiply the power. And since the bases are the same, that means I have -1 times 6x plus 4 must equal to the 2 times the x minus 5 is my equation. So then I can just solve from there. I got -6x minus 4 is equal to 2x minus 10. I have 8x equals to 6. So x is going to equal to 3/4. And there we go. Okay. Now, we're going to see a problem like this as well. Now, these problems here, however, are a little more difficult, right? So, again, I want to try to do the same base, but this is, and there's a different reason why I'm trying to find the same base here. So, I know I can write 4 as 2 squared, right? So I know that I can write this as 2 squared raised to the x power, and then the rest are the same, okay? So here's the tricky part. If I'm correct, would you agree that 2 times x and x times 2 mean the same thing? Either way, I get 2x. And you're thinking that I'm going to multiply those together. Not quite. I'm going to actually flip-flop them. So I'm going to say 2 to the x squared, because, again, 2 times x is going to give me 2x. X times 2 also gives me 2x. Agreed? Okay. So minus, and I'm going to change. I want to keep this as in red as well, and then minus 12 is equal to 0. So I have something squared minus that same base to the first power minus 12 is equal to 0. So doesn't that look kind of like, here, let me do this as well so that I can have some room to the right here. I'm going to do this, guys. I'm going to let 2 to the x be u. Ooh, a u substitution. So would this be u squared minus u minus 12 is equal to 0? Ooh, now that looks much more familiar, right? So that looks like actually like a quadratic. So if I was to factor this, wouldn't this be u minus 4? U plus 3 is equal to 0. So I have u is equal to 4 and u equal to -3. So now I can again put this back in. So let me put 2 to the x back in here. So now I have 2 to the x is equal to 4, and 2 to the x is equal to -3, okay? The one on the left, well, 2 to what power gives me 4? Well, x has to be equal to 2, right? I can get that for sure. Actually, let me not box that yet. How about this one right here? 2 to what power gives me a -3? Nothing, right? So I have to reject this because this can't work. 2 raised to any power would never give me a negative number. So that's the reason why this is my only answer. Right there. All right? Okie dokie. So that is probably the hardest type of problem because it's u substitution. But most of the problems you're going to see is where you just want to try to get a common base. Right? And of course, your follow-up question should be, well, what if I can't get the bases to be the same? Great question. We'll answer that in just a couple minutes. All right? So let's continue on to expanding and condensing. These rules here are based on expanding and condensing, okay? So again, these 3 columns are saying the same exact thing 3 times, except with different logs, right? The regular log with a base, a natural log, and a common log. So please don't think that there's 9 rules here. There's only 3, right? The product rule saying if you multiply those two, you have to split them up to 2 logs and add them. Hence, that is expanding. I went going from 1 log to 2 logs, that's expanding. If I go from these adding to this multiplying, that will be condensing. And if I divide, I'm subtracting. And if I raise it to a power, the power comes up as a coefficient, okay? So this is going to apply to most of our logarithmic and exponential equations, all right? So with that being said, now we're heading into, actually, you know what? Nope, I'm not going to do these. Hold on. These are great questions, but not done here. Hey, look at that. What I'm going to do here is show expanding and condensing, right? So let me go ahead and do examples of that, and then we'll talk about equations later, all right? So, for example, if I took the log base A of, let's say, x times the square root of x squared plus 1, right? What I see here is that I see multiplication. So if I'm multiplying, I'm going to add. So I'm going to say, okay, this is going to be the log base A of x plus the log base A of the square root of x squared plus 1. Now, this right here can be written as a power, the square root, right? So everything kind of stays the same. Except this now is going to be x squared plus 1 raised to the 1/2 power. And with that being said, what happens with that power? According to this rule right here, it goes up to the coefficient. So the 1/2 now comes up front, and that, ladies and gentlemen, would now be my answer. Now, is it going to tell you to expand or condense? Yes, but how about if I put it this way? If you're given 1 log, that means you're got to expand to multiple logs. If you have multiple logs, that means you got to condense down to 1 single log. All right. So what if I'm given something a little more dramatic? So let's say we're given log base 2 of 7 plus 3 log base 2 of 4, right? So I look at the base 2. Can I make 7 a base of 2? No. I see the base of 2. Can I make 4 a base of 2? Yes. Okay, so let's do that. So 4 is going to become 2 squared, right? Okay, great. So what do I know about this right here? Log base 2 of 2. Do you guys remember? Trying to color very slowly for you guys to do that. Yes, they cancel each other out, right? And then the 2 just becomes regular, all right? So now I'm going to have and this is going to be plus 3 times 2. So I'm now going to have a log base 2 of 7 plus 6. But I'm not condensing though. You know what? Let's do this. What if I took a traditional path? Let's see what we get here, okay? Let's change this back to black, and let's say we don't even recognize that. So here I have addition, so I think of multiplication, but better yet, let's talk about just this part right here. So let's change that to purple. That is a coefficient, so I should be moving it as a power, okay? So now it's going to be this power right here. All right. Now I see this addition, right? And that addition means, if I was to go backwards, multiplication. So it should be log base 2 of 7 times 4 to the third. So this should equal to log base 2 of 7 times 4 to the third is what, 64? That would be 4 times 4 times 4, which is equal to log base 2 of 8 carried to 2, 42, 448. Okay, so this will give me a number. Okay, this will actually give me a number. But I'm going to leave it like this for now. Actually, I won't leave it like this. Where's my calculator? So let's take it. So log base 2, so it'll be 448 log divided by 2 log. So this is approximately 8.8-ish. Okay, so now if we go back to the other way that we were talking about, and did it as what we did do. So let me do it this way here. Actually, let's do this, bring it over here as a second method, and bring this down here. All right, so if we did it this way, we said that, number one, let's keep that 3 regular, and we notice this part right here, right? So let's change, oops, I don't want to duplicate it. I want to change it red. And I said everything else stays the same except that is to the second power. So this would be 2 squared. All right, and we said that these two right here should cancel each other out. So what I have here is log base 7 of 3 times 2. So what I have is log base 7 plus 6. So let's see what that equals to. Okay, so we have, take the log of 7 divided by the log of 2 and add 6 to it. And this will also be approximately 8.8. So both of these would be correct as an answer. Okay. All right. So question is, do they want you to condense it? But either way, I have real numbers for the base and real numbers of what I'm taking the log of, so those will work for sure. All right. Well, I hope this helps. If there's any questions, please let me know. See ya. Bye.